In the last lecture, we discussed regarding the memory organization of 805 or microcontroller. Right now, we are going to see the few important registers of this 8051, and from that, the one important register is uh, PSW, that is a program status word. So, in this lecture, we are going to cover this program status word and some another important registers, okay, one by one. Now here, as we see that uh, as this program status word, uh, for this as a memory selection, there we a little bit we have to take its the information there, but not it is in a detail. That is to select the register bank, bank 0, bank 1, bank 2, and bank 3. There is the requirement of the PSW. And at that time, I told that we can see after this article in detail the program status word. And now is the time that is to see this program status word. It is in detail. Okay. Now here this is this program status word has the uh, 8-bit length. It has the 8-bit length. In it has the some flags are there. That is while the instruction is to be executed at that time, to what is the condition is there of that execution of that instruction, and that is to be see here with the help of the flags. So what are the flags are there? These flags are few flags are here in this program status word, and the few flags are in power control register. That also we are going to see after this in the next lecture there. Now here, as we have to say that is what is the program status word? This program status word is an 8-bit register. It is bit addressable. It is a bit addressable, and it gives the status of execution of the instruction. Okay, depends on what is the status of the flag is there. So actually here we have to say that the program status word is correlated with the flags. It is correlated with the flags as well as with the bank selections, as well as the memory bank selection. Now here, as we see that there are the two types of the flags are there in this 8051 microcontroller, and which are these are the two flags are there. That is, if you see this uh, highlighted sentence, there are the two flags. One is the math flag and other is the general purpose user flag are there. So what are the math flags are there? There are the 4 math flags are there. Okay, which are these as a math flags? That is, if you see that there are the 4 math flags and 3 general purpose flags are there. Okay, now these 4 math flags, that is first is that the here it is the carry flag, auxiliary carry flag, then overflow flag, and the parity flag there. So it is here is to be shown that it is the carry flag, auxiliary carry flag, overflow flag, and the parity flag. These are the 4 math flags. These are the 4 math flag. That is, these are reflected after there is the some mathematical calculations. Okay, so what is the meaning is that also we are going to see one by one in detail. Okay, and there are the 3 are the general purpose flags, which are these. Here are the F0, GF0, and GF1 there. Now if you see that the general purpose flags, that is from the general purpose flag, one flag it is in a this PSW register, and other 2 flags are in power control register that we are going to see afterwards. Okay, so as we see that here, there are totally the 5 flags are here in this PSW register, which are that here the carry flag, auxiliary carry flag, overflow flag, parity flag, and flag F0. Flag F0. That is, here it is the carry flag, auxiliary carry flag. This is the general purpose flag. Okay, then you have the overflow flag and the parity flag. Okay, so in this 8-bit register, there are the 5 flags are there. from this, 4 are the math flag and 1 is the general purpose user flag is there. Okay. Now, for this as a flags, what is it? The names are given because as I told that it is bit addressable register. As we see that it is in a what we have to say that the memory organization. It is here there. It is a program status word. It is a program status word. As it is a star in the sense it is a bit addressable register. It is in a special function register. That is PSW is one of the SFR. It is one of the SFR and it has the address of D0. It has the address of D0. Okay. So here as we see that what is your the locations of your these flags, that is carry flag is at PSW.7, then auxiliary carry flag is at PSW.6, F0 that is general flag is at PSW.5, then RS1 that is a register bank select 1, okay, it is as PSW4, then RS0 that is register bank select 0, it is at PSW.3, overflow flag here PSW.2, here is no any assignment for the PSW.1, okay, it is a blank, and the parity flag at PSW.0. So if you see that what is your the what we have to say that the what is the address of the parity flag, it is a D0. Then what is the address of the carry flag, it is D2 there, it is 0 1 2 there, okay. Then what is your the address of the carry flag, it is D7, it is D7. What is the address of the auxiliary carry flag, it is D6, it is D6 is there as it is a bit addressable, okay. Now here as we see that your the what is the carry flag, that is the carry flag, it is a conventionally called as the carry or the borrow flag. That is this carry or the borrow flag is utilized at the time of the arithmetic operations, okay. That is if the carry is to be generated from one column to second column, or while the subtraction there is the carry is taken from the next column, then there is the borrow is generated. So for this purpose this carry flag is utilized, and this what is the carry is that you learn it is in a FYBAC in digital fundamental, okay, while they're doing the arithmetic operations, okay. At the same time this carry flag is also utilized for your the boolean accumulator, in the sense when your the boolean instructions are operated, when the boolean instructions are operated, these boolean instructions are operated at bit level, okay. So at that time also these carry flags are reflected, and so it depends upon that the programmer knows that what the result is coming there. That is when we are going to see the instructions in a second topic and the third topic in detail, at that time you come to know that how this carry flag is utilized for your arithmetic operations and your the bit as boolean accumulator operations are there, okay. So this is the carry flag. Then next is the auxiliary carry flag. Now when we have to go to see as an auxiliary carry flag, this auxiliary carry flag is normally utilized for your the BCD operations. That is for the BCD arithmetic. That is when we are considering about the BCD arithmetic is there, at that time auxiliary carry flag is utilized there. At that time the auxiliary carry flag is utilized, because in BCD arithmetic there is the lower nibble and the upper nibble, it forms your the 1 byte of the data is there, is 8 bit of the data, lower 4 bit and upper 4 bit. So if there is the carry from lower bit to upper bit, then your the auxiliary carry flag is reflected. So it is here we have to say that it is utilized for the BCD arithmetic, that is a binary coded decimal arithmetic. You also know that what is the BCD arithmetic in your the BSc 1, you already studied there, okay. Then you have the flag 0. Now this is the general purpose flag used for programming, okay. So right now we are not going to see this detail here. Then you have the RS0 and RS1, that is a register bank select 0 and a register bank select 1. That is these are utilized to select the register bank, that is by its name there, by its name there. And if it is not selected, then by default your the bank 0 is selected. Okay, so here now you are the overflow flag. Now, when we have to say that you are the overflow flag, that is when there is the arithmetic operations are going on. At that time, if there is the overflow is there, that is to be indicated by this overflow. That is in 8th column of your the 8-bit addition or any arithmetic operation. If there is the carry is to be generated, that is to be reflected by this overflow flag. When we are doing the program at that time, we can come to know in detail there. Then you have the even parity flag. There is a P0. Now this is for your the what is the parity of your the data. Okay, this parity flag is accumulator parity flag. Okay, so what is your the data? It is an accumulator. Its parity we can get. That is, if you set its value 1, then we have to say that your the number of ones are odd or even there, that we can find out there. That is, if this is the 1 there, then we have to say that the parity bit is to be even. So this is your the for the parity bit, parity flag is there. Okay. Now all these program status word is totally summarized in this one table. That is, from this table we come to know that how the things are happening there. That is, now we have the bit 7. It is C or C1. That is the carry flag. Okay. Here the name of the flag name, carry. For what purpose it is used in arithmetic, logic, and Boolean operation. Then bit number 6. Okay. It is auxiliary carry. No? Used in BCD arithmetic. Then bit number 5, it is F0, flag 0, general purpose user flag. Then bit 4 and the bit 3, these are RS1, RS0 respectively. What is it the name? There is a register bank selection 1 and the register bank selection bit 1 there. Okay, 1 bit is there. So with the help of that, that is, if you take your the 2 bits are there, then we have to getting the 4 combinations are there. There is 0 0, bank 0 is selected, 0 1, bank 1 is selected, 1 0, bank 2 is selected, and 1 1, bank 3 is selected. Okay. Then bit 2 is there. This is the overflow field. That is, this is used in arithmetic operation. Then bit 1, that is, it is reserved there. It is reserved there. This may be utilized in some complex programming for your the general purpose flag. User may or the designer may use this. Then you have the 0th bit. There is a 0th bit. It is the parity bit. That is, it set to 1 as accumulator is odd. Okay, what is it to be data? Otherwise reset. That is, these are to be utilized. So this is about your the program status word. It is whole about the, that is, if you remember this chart, then you come to know that how the program status word will be work there. Okay, so next, right now we go for your the next part, that the stack pointer. Okay, stack pointer is also another one, SFR. Okay, as we it is the SFR. Okay, it is also the SFR and its address is 81H is there. It is not bit addressable. It is byte addressable. Now what is the stack? Okay, there is stack. What we have to say that it is some part of the RAM is utilized by the central processing unit to store the information. Okay, it is the same way that is we are for example, if you have to say that the books or the notebooks we are put it is in a stack in our self there, it is in a home there. Same is the condition. म्हणजे घरामध्ये जसं आपण आपला नोटबुक किंवा पुस्तक ही एकावरती एक रचून ठेवतो, बरोबर का? जे पुस्तक आपण वरती ठेवतो तेच पुस्तक पहिल्यांदा काढावं लागतं आपल्याला, बरोबर? खालचं पुस्तक आपल्याला काढता येतं का? नाही. त्यासाठी आधी वरचे पुस्तक काढावं लागतं, मग खालचं पुस्तक. दॅट इज जे लास्ट पुस्तक वर ठेवतो तेच पुस्तक पहिल्यांदा बाहेर येतं. ओके, इफ यू टेक इट इज अ स्टॅक वन बाय वन. ओके, so here we have to say that this stack is a some part of the RAM. It is used by the CPU to store the information, and this information is a temporary information. Okay, it may be your the address or the data, whatever may be that. That is this storage of your the information by the stack. It may be the data or it may be the address, but it is the temporary. Okay, and here the some limited registers are to be utilized. Now here for this as a stack pointer, okay, it is a 8-bit wide there, and as it is the 8-bit wide, we have to say that it has the capacity of 00 to 002 FF. This much amount of the strength is there. That is stack we can adjust with from, as it is a 8-bit, it is from 00 to FF. But when we have to reset the stack pointer, then the stack pointer is at the location of, it has the content, the address, it is the 07H on power on reset there. That is the stack is at the location of the RAM 08. Okay. So what is the 08th location is that is it is the address is the 07. That is what is the address of the stack on the reset. It is a 07. Okay. Then as we have to say that you have the stack there. This as a stack pointer, actually it is a small register, okay, that stores the address of the last program request in the stack. Okay, so here we have to say that the stack is nothing but a specialized buffer. Stack is nothing but the specialized buffer which stores the data from top down. That is, it will be store the data from top to down here. Okay, so as a top down is there in the sense, as we have to give the request there to store the data, it will be send or to push the older the data down, and the new data is to be stored on the top. New data will be stored on the top there. It is the same way that अजून एक तुम्हाला मी एक्झाम्पल देईल. घरामध्ये आपण किचन मध्ये एक लक्षात ठेवा की आता एकदा आपण एक 10-15 चपात्या करायच्यात आपल्याला. घरातली माणसं एवढी आहेत की आपल्याला 15 चपात्या रोज लागतात असं समजा आपण, बरोबर का? मग 15 चपात्या लागत असेल तर पहिली चपाती खाली जाते ना, नंतरची चपाती वर येते, नंतरची वर येते, आणि जेव्हा तुम्ही वाढायला सुरुवात करता तेव्हा खालची चपाती अगोदर काढता का? नाही, वरचीच चपाती वाढता ना. सेम तेच लॉजिक इथे वापरलं जातं. सेम तेच लॉजिक इथे वापरलं जातं. दॅट इज हिअर व्हॉट हॅपन when we are storing the data in a stack pointer, it push down the older data and the new data is stored on the top there. Next time when we are storing the new data, then what is the stored data will be further pushed down and the new data is stored on the top. And when we have to recall the data, when we are recall the data, that is this recall of the data, that is top of the data we take first, top of the data we take the first, that is most recently data which is to be entered, it is to be taken first out there. So due to that, the operation of the stack pointer is last in first out. Last in first out. म्हणजे स्टॅकचं ऑपरेशन, स्टॅक पॉइंटरचं ऑपरेशन कसं आहे की जे तुम्ही लास्टला स्टोअर करताय ते पहिल्यांदा बाहेर काढताय, बरोबर? जे पहिल्यांदा स्टोअर करताय ते लास्टला आउट येत आहे. ओके, दॅट इज फर्स्ट स्टोअर इट कम ॲज अ लास्ट आउट, अँड व्हॉट इज युअर द लास्ट स्टोअर इट कम ॲज अ फर्स्ट आउट. लास्ट इन फर्स्ट आउट हे तुम्ही रेजिस्टर मध्ये शिकलाय सेकंड सेमला, फर्स्ट इयरला सेकंड सेमला शिकलाय की तुम्ही लास्ट इन फर्स्ट आउट, लास्ट इन फर्स्ट आउट. तसंच तुम्हाला आता इथं काय करावं लागेल ते करावे लागेल. ओके, सो हाऊ द स्टॅक पॉइंटर इज वर्क, it is last in first out. It works, it is in a last in first out. Remember, it is for the objective there. Okay, now for this purpose there are the two type of the operation are done there. That is, one is the push operation and other is the pull operation. That is, here we have to say that when we are doing this as a stack pointer operation to enter, that is when the new data is to be entered, or it is a pushed there on the stack there. म्हणजे तुम्हाला डेटा जर त्यामध्ये स्टोअर करायचा असेल तर तुम्हाला काय करावं लागतं, न्यू डेटा स्टोअर करायचा असेल किंवा एंटर करायचा असेल तर तुम्हाला त्या ऑपरेशनला काय म्हणलं जातं, पुश म्हणलं जातं. ओके, आणि जर तुम्हाला स्टोअर केलेला डेटा जर काढायचा असेल सेव्ह केलेला डेटा हा स्टॅक पॉइंटर पासून जर काढून घ्यायचा असेल तर त्याला म्हणलं जातं पुल्ड ऑर पॉप्ड. त्याला काय म्हणलं जातं? पुल्ड ऑर पॉप्ड म्हणलं जातं. ओके. So when the data is pulled or popped from the stack, that is your the data is to be come as a out there. Okay. So these are the some what we have to say that the operations are there for the push and pop there. For the push and the pop, these are the operations are there. Okay, that is here for the stack pointer, you have to remember that there are the two important operations are that one is pushed and other is the popped. Pushed in the sense storing the data and popped means calling the data or retrieving the data. So how these things are happening, that also we have to see here. So here for push and popping the data, there are the two instructions are that instruction also we are going to see it is in detail in the next second and the third topic. Okay, so these instructions are called as push instruction and the other instruction is called as a pop instruction. That is here for storing the data in stack is called push, and the pulling the content of the stack back from this into the CPU register is called as a pop. So the pop and the push, these are the two important instructions. These are related to stack pointer for storing the data in a stack, the data or the stack in data or address in a stack, or retrieving the data or address from the stack. There is the pop instruction is there. Now what it's the working is that, as we have to say that the working, that is first, as it is on the reset, we are at the 07th location. We are at the 07th location is there. Okay. So automatically what happens when we store the data, automatically the address of your the stack pointer is incremented by 1. Okay. So here what see that as here is the thing, as a stack pointer is at the 07 address on the reset there on reset. So what is the content we have to storing, that will be stored here and it will be go to the next location. So the next data which is coming for the 08 location, it will be stored at that address. And once your the second data is stored at the address 08, immediately it will be incremented automatically to 09 location. That is 09H. When we store the data in 09, it goes here in that address as a internal RAM is here. Here is the stack is there. This stored here. And further that the next address comes at a 0A where the data we are storing, it goes here. And when we are retrieving the data, that is calling the data by the popping instruction, that is a pop instruction is there. So what happened? The last at this address 0A, what is the data we have to store? That is a 0A. This will become out there, and automatically the stack pointer will be decremented by one location. That is, when we are storing the data, the stack pointer will be incremented by the one location by the push instruction, and when we are retrieving or calling the data from the stack pointer will be decremented by 1. At that time the instruction is utilized, it is the pop instruction. म्हणजे ज्यावेळेस तुमची पुश इन्स्ट्रक्शन ही वापरली जाणार त्यावेळेस स्टॅक पॉइंटर हा 1 ने इन्क्रीमेंट होणार, आणि ज्यावेळेस तुम्ही पॉप इन्स्ट्रक्शन वापरणार त्यावेळेस तुमचा स्टॅक पॉइंटर हा 1 ने डिक्रीमेंट होणार. ओके, सो दिस इज द कंडिशन इज हियर. ओके, so one by one it is going to decrease, that is get down, further it is get down, and we come at the it's the original location at the 07 address. Okay, म्हणजे स्टॅक पॉइंटर असा आहे की एक ते मेमरी लोकेशन आहे रॅमचं 8 बिटचं आहे, त्याचं टोटल 8 बिटचं असल्यामुळं त्याची जी कॅपॅसिटी आहे ती 002 FF आहे. आणि ऑन पॉवर ऑन रिसेट म्हणजे ज्यावेळेस तुम्ही रिसेट करता मायक्रो कंट्रोलर त्यावेळेस स्टॅक पॉइंटरचं जे ऍड्रेस आहे तो 00 नसून तो काय आहे 07 आहे. आणि त्या ठिकाणी ज्यावेळेस तुम्ही एखादा डेटा किंवा ऍड्रेस 8 बिटचा स्टोअर करता त्यावेळेस स्टॅक पॉइंटर ऑटोमॅटिकली 1 ने इन्क्रीमेंट होतो, आणि स्टोरिंग करायला जी इन्स्ट्रक्शन लागते स्टॅक पॉइंटरसाठी त्या इन्स्ट्रक्शनचं नाव आहे पुश, आणि त्याला ऑपरेशनला काय म्हणलं जातं पुशिंग ऑपरेशन म्हणलं जातं. बरोबर का? आणि जो डेटा तुम्ही तिथे स्टोअर केलेला आहे तो डेटा तुम्हाला डेटा किंवा ऍड्रेस 8 बिटचा काढून घ्यायचा असेल, पुल आउट करायचा असेल किंवा रिट्रीव्ह करायचा असेल तर त्या ऑपरेशनला म्हणलं जातं पॉप ऑपरेशन ऑर द पुलिंग ऑपरेशन. ओके, पॉप or pulling operation, and that is to be done by the pop instruction. That is to be done by the pop instruction. And while the pop instruction is executed, the stack pointer is automatically decremented by one location. म्हणजे push instruction it will be incremented by one location, and by the pop instruction it will be decremented by the one location. You remember this that for the objective there. Okay, so stack pointer related operations are done by the two instructions, push and pop. Okay, you remember that. And at the same time, if you see that how many instructions are used while stack the pointer, these are the instructions are here. There is a push instruction, pop instruction, long call instruction, return instruction, and return interrupt instruction. Okay, so these instructions are used while the access the stack pointer. म्हणजे जर तुम्हाला स्टॅक पॉइंटर जर ऍक्सेस करायचा असेल तर तुम्हाला ह्या 4 इन्स्ट्रक्शन्स काय करावं लागतात, वापरावं लागतात. पुश, पॉप, कॉल, लॉंग कॉल, रिटर्न अँड रिटर्न इंटरप्ट. ओके, ऍट द सेम टाइम टू मूव द दॅट इज टू इनिशियलाइज द इन्स्ट्रक्शन. आता जसं मी तुम्हाला सांगितलं की ऑन पॉवर ऑन रिसेट इट्स ऍड्रेस इज 0.7, पण असं काही नाहीये की तुम्हाला जर कुठल्याही लोकेशनला म्हणजे फ्रॉम 00 टू FF त्यातल्या कुठल्याही लोकेशनला तुम्ही स्टॅक पॉइंटर इनिशियलाइज करू शकता. कुठल्या लोकेशनला तुम्ही स्टॅक पॉइंटर काय करू शकता, इनिशियलाइज करू शकता. मग ते इनिशियलाइज जर तुम्हाला करायचं असेल तर वी हॅव द वन इन्स्ट्रक्शन दॅट इज द मूव स्टॅक पॉइंटर हॅश 0xxh. That is there we can initialize the instruction, initialize the stack pointer as per our address. म्हणजे पॉवर ऑन रिसेट केला तर तो 07 लोकेशनला जाईल. समजा तुम्हाला असं वाटतंय नाही मला स्टॅक पॉइंटर इनिशियलाइज कुठं करायचं आहे, 10h ला करायचं आहे, तर तुम्ही इथं मूव SP हॅश 10h टाकलं की स्टॅक पॉइंटर कुठे इनिशियलाइज झाला, 10h म्हणजे 10h लोकेशनला तो इनिशियलाइज होईल. इट डिपेंड्स अपॉन यू. म्हणजे फक्त 00 टू FF ह्या मधल्या कुठल्याही लोकेशनला तुम्ही स्टॅक पॉइंटर हा इनिशियलाइज करू शकता, डिपेंड्स अपॉन युअर नीड. Okay, so this is total about the stack pointer. Now next important register is that DPTR, that is a data pointer. आता दुसरा important register आपण बघूया, data pointer. Okay, it is DPTR. Now this DPTR is also the one of the SFR. It is a special function register, but it is the 16 bit. It is the 16 bit, but our microcontroller is 8 bit. That's why the data pointer has its the two registers, that is the DPH and DPL is there. And we see in special function register table that there are the two registers. DPL it has the address of 82H and DPH it has the address of 83H, and combining these two it's happen one DPTR 16-bit address there. Okay, here also we can take the one example there how we can say that it is a DPTR register is there. Okay, now for this as a DPTR register how these things are happening, that also we can see. So for this purpose one example is here by this program. That is if you want it is in a 46 value, that is in a external. And one thing is also remember that this DPTR, this instruction, that is the data pointer instruction, it is normally, that is it is specially used for your the address of your the external code or data memory. म्हणजे एक्सटर्नल डेटा किंवा कोड मेमरी जर तुम्हाला ऍक्सेस करायची असेल, म्हणजे एक्सटर्नल मेमरी जर ऍक्सेस करायची असेल तर देर इज द नीड ऑफ द डेटा पॉइंटर. अदरवाइज इट इज नो एनी नीड of your the data pointer if you are accessing the internal memory of the microcontroller. Okay, for the external code or data memory जर तुम्हाला access करायची असेल, that is if you want to access external code memory or the external data memory, in such situation we are requiring the data pointer. Now suppose that for the external location of your the we want to write 46. That is here the one example. That is in this example, the user want to write the value of 46H to the external memory location at 2500H. There is 2500H at that location we wants to store. So here it is a move A. That is how these instructions are that it is a move A hash 46H. It is move immediate 8-bit data 46H to accumulator. Then move DPTR hash 2500H, that is load data pointer with 16-bit address value, that is 2500H. Then you are the in such situation, that is we are initialize this data pointer at 2500H that location, and in such situation what are your the two registers are your the data pointer, that is DPH and DPL. What it holds, that is the DPL holds 00H and DPH holds 25. Okay, then the next instruction is that move X at DPTR A. And what happened? What is in an accumulator? Accumulator there is the 46. This is the right now move to the, it is a relative addressing. So how this addressing mechanism is there, that we are going to see it is in a detail in second and the third topic. So right now only you see that what is to be happening. Okay, so this will be see it is in more detail, that is how it is moving there. Okay, now here this move X, that is what the is utilized, that is the move X is instruction used to access the external memory. Okay, म्हणजे एक्सटर्नल मेमरी जर ऍक्सेस करायची असेल तर मूव एक्स करावं लागतं तुम्हाला, तर ते आपण त्यामध्ये डिटेलमध्ये बघू सेकंड आणि थर्ड टॉपिक मध्ये. सो दिस इज अबाउट युअर द डेटा पॉइंटर. ओके, सो द नेक्स्ट वी आर गोइंग टू सी एज अ इम्पॉर्टंट रजिस्टर is accumulator or B register, accumulator and B register. Now here the accumulator is the most important register of the CPU, because all the arithmetic and the logic operations are done, or what are the results are there, all these are holds in accumulator. So accumulator is one of the important or the crucial register of your the CPU. Okay, now the accumulator is of 8-bit register. Okay, as the microcontroller is 8-bit. Okay, this accumulator has it the address, it is 0EH. Okay, this accumulator we can increment or the decrement by the 1, depends upon your need. Okay, if you take as a for example as a there, that is a how we can load the accumulator with your the data there. म्हणजे जर आता 52 हा डेटा जर तुम्हाला अॅक्युम्युलेटर मध्ये लोड करायचा असेल तर आपण दोन प्रकारे करू शकतो. म्हणजे त्या दोन्ही इन्स्ट्रक्शननी सेम काम होणार आहे, वेगळं काम होणार नाही. जी इन्स्ट्रक्शन पहिलं काम करेल तीच इन्स्ट्रक्शन दुसरं पण काम करेल, ह्यामध्ये कुठलाही वेगळा फरक नसेल. फक्त इथं वी आर लोडिंग द 52H डेटा बाय द नेम, म्हणजे ह्याच्यामुळे काय होणार आहे की अॅक्युम्युलेटर मध्ये 52 लोड होणार आहे. आणि इथं काय करतोय आपण मूव 0E0H, म्हणजे काय करतोय की इथं पण 52 हा डेटा E0 ह्या लोकेशनला स्टोअर ठेवते. आणि E0 हे लोकेशन कोणाचं आहे, जर तुम्ही SFR चा जर हे पाहिला काय स्पेशल फंक्शन रजिस्टरचा टेबल पाहिला तर अॅक्युम्युलेटरचा ऍड्रेस किती आहे, 0 E0 आहे. अॅक्युम्युलेटरचा ऍड्रेस काय आहे, E0 आहे. त्यामुळे E0 ह्या लोकेशनला काय होईल तुम्हाला 52 हे स्टोअर होईल. म्हणजे पहिली इन्स्ट्रक्शन वापरायची का दुसरी, दॅट इज वेदर टू यूज द फर्स्ट इन्स्ट्रक्शन और द सेकंड इन्स्ट्रक्शन इज टोटली डिपेंड्स अपॉन द designer or the program designer. Okay, both instructions do same job, nothing the change that. That is one instruction is by name of the SFR and other instruction is by the address of the SFR. Okay, now this is about your the accumulator. Now another important register is the register B is there. Okay, now the register B is Also here we have to say that it is important register, and this B register is mainly utilized for the purpose of multiplication and the division. And if it is not utilized for the multiplication and the division, in such situation, this can be utilized as a ordinary memory for the storing the data. म्हणजे जर तुम्हाला बी रजिस्टर हा तुम्ही मल्टिप्लिकेशन किंवा डिव्हिजन साठी वापरले नाही, हा रजिस्टर जर नाही वापरला, तर अशा कंडिशन मध्ये आपण साठी वापरू शकतो. ओके. आणि बिट ऍड्रेसेबल आहे, हे दोन्ही पण बिट ऍड्रेसेबल. म्हणजे तुम्ही जर SFR मध्ये जर बघितलं तर SFR मध्ये तुम्हाला जाणवेल अक्युम्युलेटर आणि बी रजिस्टर हे दोन्हीही रजिस्टर बिट ऍड्रेसेबल आहे. आणि बी रजिस्टरचा ऍड्रेस हा किती आहे, F0. म्हणजे लक्षात ठेवायला पण किती सोपं आहे बघा. E0 हा ऍड्रेस अक्युम्युलेटरचा आहे. ओके. E0 हा ऍड्रेस कोणाचा आहे, अक्युमुलेटरचा इथं पाहिलं तर. आणि F0 हा ऍड्रेस कोणाचा आहे, बी रजिस्टरचा आहे. ओके. So this is about the accumulator and the B register. Now the next is the program counter. Next is the program counter. If you have to see that this program counter is of the